Alrighty, everyone, welcome back to the final series in our webinar series on configuring your AKS cluster with confidence. That was the first session. Then we moved forward and talked a little bit more about securing your AKS cluster and thinking about things like governance and compliance. And now we're going to talk a little bit more about the workload capabilities on AKS, some of the great work we're doing in the Azure space, especially in bringing in some of these open source projects. And then we'll kind of talk through and provide some additional links for you to continue learning and growing in your AKS journey as we wrap up the last session. So thanks all who are returning with us. And if you're here with us for the first time, once again, feel free to refer back to the videos in this playlist so that you can get a good idea of what we covered in the previous sessions. So today's agenda, not too complicated, do a quick welcome and introduction, talk a little bit about some of the more developer-centric AKS considerations. Then we'll talk through some cloud-native themes that Ray and myself particularly see in our space working with customers, and kind of dive into a few of the different technologies or resources you can use to dig deeper into these areas and be more, more optimized in the way that you interact with your AKS cluster, especially from the developer's perspective. And then we'll talk a little bit about some of the app innovation and just general innovation on Azure in the AKS space and some of the other ways we are bringing Kubernetes and other open source projects into the platform. And then we'll do a quick review before, once again, we kind of let you go. Thank you for joining and pass off some additional links for you to continue your learning in these areas. So if it's your first time here, I'll do a quick introduction. My name is Kendall Roden. I'm a technical specialist on the Cloud Native Global Black Belt team at Microsoft, co-host of the Azure podcast, and pretty passionate about open source. Have had the opportunity to shadow a couple of releases on the Kubernetes upstream team, and so really enjoyed that experience and just getting my hands deeper into the open source community. And then if you want to connect with me after the session, feel free to check out my Twitter or connect with me on LinkedIn. I'd love to keep the conversation going. So I'll pass it over to Ray. Make his job easy since we have pretty much the same title.
Yeah, keep it short and sweet. Love following a team member. Rayco, same team, same role as Kendall. You can also follow me on Twitter or GitHub, Rayco. So that's it.
Perfect. Thanks, Ray. So wanted to talk a little bit more and just do a quick recap of the things that we covered in the first two sessions. We won't be covering really any of this today. We won't be rehashing things we've already discussed, but want to encourage you to go check these things out. So just keep in mind, for a frame of reference, we've essentially gone through setting up a cluster and then optimizing that cluster to make it more secure. And so we went through these four pillars: the compute and infrastructure, process, networking, and observability, in order to really break down some of the considerations within each of these areas, talk through some of the best practices that you can leverage. And so if you're interested or see any of these topics that jump out to you, feel free to check out those previous sessions to dig a little bit deeper there. And also there's a lot of great content around these subjects, on the Microsoft Docs website and in several of the walkthroughs that we'll be linking to the GitHub repo. So, highly encourage you to definitely think through how you can set up a cluster baseline or a secure cluster that you feel confident with, that you can reproduce and recreate. And then once you've done that, you can really take a look at how you're going to run your workloads on top of the cluster and take advantage of some of these other open source projects that allow you to really extend your capabilities on AKS specifically, and really generally Kubernetes anywhere. So we've talked a lot about Kubernetes on Azure. We've talked a lot around what AKS provides, but really I think we've also done a decent job in emphasizing, especially in the security and governance bit, the importance of the overall Azure platform from a security and governance perspective. So, AKS is great and provides a lot of great functionality, but, why run Kubernetes specifically within Azure? And I think one of the more compelling reasons is because of these other platform integrations. So we've talked about things like Azure Active Directory, using that to secure access to your cluster, to secure the different authorizations and roles that a specific authenticated user can have within your cluster. We've talked about Azure policy, not just at the subscription level, the resource group level, the management group level, all that's good, but really pushing that down even to the cluster level. And then we've talked about great integration with things like Azure Key Vault and Security Center to make sure that you are following best practices in terms of keeping your cluster secure and definitely getting those secure credentials into the cluster. And then not only that, but we have a lot of other ecosystem, community integrations that make AKS and Kubernetes on Azure very compelling, and have been really active in contributing to several of the major open source projects that support Kubernetes. Things like, KEDA, Helm, coming out of the Azure team or of the Microsoft team, and a lot of other great investments that we've made in order to help bridge the open source ecosystem with things on Azure. And so on top of that, we also really haven't touched on, but we'll touch on today, some of the integrations with development tools like Visual Studio Code. We've talked a little bit about Azure Container Registry and some strategy there in webinar 1. And then we also talked about Azure Monitor and ways that you can light up that container insights on day 1 to make sure you're really getting visibility into your cluster. And then today we'll also be touching a little bit on some of our management platform through Azure Arc. So finding a way to take and manage Kubernetes running anywhere, be it in Azure, other cloud providers, or on premises, and providing some of these same platform pieces of functionality in order to secure or govern that particular cluster. And so this is really the overarching story of this entire web series. Is there's a ton within Azure that makes running on Kubernetes really compelling, especially bringing that Kubernetes cluster to Azure. But we're also finding ways to adapt and respond to the growing open source community and the need for this multi-cloud strategy. So I think that leads really well into some of the cloud native themes that we're seeing. So in terms of application development, we've talked about the fact that traditional application development, monolithic applications, that's what people are typically familiar with, but we see this pivot toward more event-driven, distributed, microservice-based applications and architectures. And so both Dapr and KEDA, really compelling open source projects that Microsoft has been heavily invested in, that we'll talk about today, that help make building these types of systems, especially leveraging Kubernetes as your hosting platform, really compelling and really exciting. And then we'll talk more about that concept of shifting left, right? So not only just from a security perspective, but also making sure that we're shifting left that developer feedback loop and making sure that the developers can continue to get a consistent debugging experience and the ability to get instantaneous feedback when trying to apply a change on a Kubernetes cluster or making a change in application code that will eventually be packaged into a container and run on Kubernetes. Then we'll talk about our hybrid and multi-cloud theme, which is what we see a lot of customers gravitating toward, right? Having workloads that are running both on premises and in Azure or potentially in multiple cloud providers. And so what are some of the strategies or things we're seeing in the cloud native community that are really enabling this? A big piece of that being GitOps or infra as code, and really using Git as your declarative source, really from an application perspective, but also from a configuration perspective. And that lends itself really well to our strategy around Azure Arc and bringing some of our platform capabilities down to or over to clusters running both on premises and in other cloud providers. And last but not least, we'll talk about our strategy at Microsoft to make some of our platform services containerized or the runtime is containerizable, if that's a word, containerizationable, however you want to say that, but basically how you can take containers and marry them to some of our platform services so that you get more flexibility in where and how you run those services. And then last but not least, just some of that deeper integration, right? Customers really want to understand, if we're not necessarily going multi-cloud, or even if we are, how do we get the benefit of each potential cloud provider we may be running in, right? So what are other ways that Azure is abstracting away complexity and providing deeper integration with some of its existing platform services, which we've seen a lot in the integration or move to bring things like Azure Active Directory and Azure Policy down to the Kubernetes cluster level. So now that we have an idea of what we're really going to be focusing on today, the first thing I want us to talk through is just some of the developer considerations that walk hand in hand with some of the considerations from an operations perspective that we've talked through in the previous web series or webinar series. So let's just touch on a couple of these very briefly. So we've talked about, we really should be setting up developers for success from an operations perspective. So when we're provisioning our infrastructure and we're thinking about security and governance, we want to make sure that we're putting guardrails in place that allow our developers to to not have to worry about some of those considerations in the sense that we put those guardrails in place. So for example, a developer really should be using pod resource requests and limits when creating application deployments for Kubernetes objects. Now, when we think about a developer creating a deployment, there's a lot of annotations that can be added to that, right? And pod resource requests and limits are just one of those. And so if a developer, does not use one of these things or, does not include that in the deployment annotations, as we would hope from a security and governance perspective, the really amazing thing is from an operations perspective, we can set a resource quota at the namespace level so that that deployment essentially fails, right? So we get a bit of that shift left because we're letting the developer know, hey, instant feedback, can't make that deployment without these requests and limits. But we're also setting them up for success because, if they were to forget a particular security or governance requirement that we do have for the cluster, we put those guardrails in place. So while we would hope the guardrails are there, we still want to make sure that developers understand and are empowered to keep security in mind and make sure that they're putting these security best practices into place without having to get that feedback through some type of policy or admission controller feedback. Another is making sure that we're limiting pod access to nodes. So just ensuring things like not running containers with the option to do privilege escalation. So making sure that flag is set to false. And just making best practice use of some of the other, especially on the Linux side, some of the other Linux primitives to make sure that that container or that pod has the least possible access to the underlying node. And I think a lot of that also goes into making sure that we are making use of some of the best practices approaches for securing credentials within our application code that's running, in a container as a pod on Kubernetes. And then last but not least, obviously, developers need to find tooling that works for them, right? For their teams, be it distributed or otherwise, the application type. You want to make sure that developers are set up for success when it comes to how are we actually going to function as a distributed development team that's working on distributed applications. And so figuring out what strategy works for your team is really critical. And different things work for different teams, and there are a ton of different approaches to recommend here. And so we'll touch a little bit on some of those, especially some that Microsoft has kind of spearheaded in the community to make Kubernetes-based development a bit easier and a bit more constructive for traditional developers shifting to a more microservice-based architecture model. So just wanted to keep those and emphasize those, in the top of our brain after some of the previous webinars where we talked a lot about some of these best practices. So we're going to go directly into those cloud native themes now to talk a little bit about more of that event-driven distributed application approach and some of the technologies that Microsoft has been working on and that marry very well with running on Azure Kubernetes Service from a development perspective. So the first one is Dapr, and this is personally a project I know I'm super passionate about and several people on my team are super passionate about because we see a lot of the value in what Dapr provides. So Dapr, if you're unfamiliar, is the distributed application runtime. And essentially, it's a portable event-driven runtime, making it easier for developers to build these resilient microservice-based applications, be them stateless or stateful, that can run in the cloud and on the edge. And I think the biggest thing here is Dapr is really trying to help developers and organizations take advantage of the diversity of languages and developer frameworks that are now being created and find a more iterative approach to being able to create new services and make decisions about the type of framework or backend services that application will rely on. So I think a lot about how traditional, we used to have a lot more traditional full .NET framework shops, right? They developed strictly in C# or ASP.NET. And so we'd hear that they're a .NET shop, right? And more we're seeing customers that want to use a diverse set of languages, and they don't necessarily want to have to think about all of the plumbing, all of the libraries, the specific SDKs within each of those languages. Because when you're learning and trying to use different languages, and then you think about all of the ramifications of that and the integrations of those various services talking to one another that may be written in different frameworks or different languages, that adds a lot of complexity. And so customers would kind of pick one train and stick with it. But we're seeing more and more of that polyglot approach as customers move toward this more cloud native form of development, and just being able to take more advantage of the way that these clouds have matured. And so when we think about moving toward microservices, right, a lot of customers have a lot of questions. How are we going to integrate these microservices with other systems? How are we going to take that event-driven approach? How are we going to do decoupled communication, fault tolerance? How are we going to make sure that we do service discovery, maybe pick up this application up and run it on a different platform, on a different cloud provider? And so, secure secret access. All of these are considerations when a customer is thinking about microservices. And I remember in my previous role, I actually worked with a customer, and what they had done is created almost this catalog, like a DevOps catalog, where they could create a template or a framework for their internal approach to microservices. So it was like, hey, we have a lot of different developers, we have a lot of different organizations, and they want to start writing microservices, but we want to make sure we have consistency. We want to make sure that these microservices, look alike, that they take a similar approach, that they're using the same secure mechanisms for things like secret access, or that they're using the same libraries for retry logic, whatever that decision might be. And so they would have a core team, whether it's the site reliability engineering team or the DevOps team, basically come up with a way that a developer could say, hey, I want to create a new microservice. And they would basically create this scaffolded project that the developer could start with. And so I really like to think of Dapr as an evolution of that. And they said, hey, there's a need for this, some kind of template, some kind of approach to creating microservices in a way that's consistent. Let's create a project that can codify some of these best practices, some of these areas, to make it where organizations can really leverage a tried and true approach to microservices development that helps abstract away complexity from developers and also abstracts away the responsibility of each of these individual organizations to create their own approach to microservice templates. So that's really what the goal of Dapr is, right? It's based on best practices and takes some of the best practices that I think the industry and the cloud native ecosystem and the community has learned from moving toward microservices and tackling some of these microservices challenges. It works really well from a language and framework perspective because it's agnostic, as all you really need to do is use a series or set of REST APIs that you can interact with regardless of what you're coding in or what framework you're using. And so then you can opt in to the building blocks you choose to use. So it's not an all or nothing solution. You absolutely get the pluggability of saying, hey, I want this feature, I want that feature, but I don't necessarily need all of them, and that's totally fine. Dapr is an open source project that came out of the Microsoft Incubations team, but it is fully open source, and that means something, right? It means something in the sense that you'll now have community support, that you're getting, you're not getting a Microsoft product here. You're really getting a community effort that takes into consideration, the wide array of needs from a wide array of organizations. And it's also portable. It can be run, really anywhere, regardless of if you're running in Azure, another cloud provider, on premises. All of that is on the table. I will say it does lend itself, lends itself well to containerization in Kubernetes. That's really the target from a deployment perspective and a hosting platform model. So let's make this a little bit more real. When I talk about pluggability, when I talk about building blocks, what does that actually mean? So within the Dapr project, as I mentioned, it really strives to codify some of these best practices. So what that means is, hey, we recognize that service-to-service invocation, things like state management, having the ability to do input and output bindings to external systems, having observability that's wired up, tracing, things like that are pretty much common in most microservice architectures or most approaches that we've seen. So how do we create a pluggable system where we can abstract away the backend implementation of each of these respective building blocks to make it easier, to use APIs instead of using, SDKs and bringing in some of this plumbing code into your core business application. So let's just touch on 2 or 3 of these building blocks to give you a little bit more of a real world example here. So for example, service-to-service invocation, right? I have 2 independent application services that are running. that when combined with a series of other services create my overall microservice-based application. So within service A and service B, I might want them to be able to communicate with one another, to hit a method from service A to service B. So how do I do that? Well, traditionally, I'd have to wire up some type of HTTP call from service A to service B. But instead, what I can do is actually call out to the Dapr runtime that's running, alongside of my application code, and use that to basically do secure service-to-service invocation, calling methods from service A to B, doing things like retry logic, finding a way to discover services wherever they're located, depending on your hosting environment. And so being able to offload that to the Dapr sidecar or to the Dapr runtime is really powerful. Same goes with PubSub, right? I really want to find a way to have a more centralized form of messaging where I can publish a message from service A, and then service B, C, and D can all subscribe. So traditionally, I'd have to pick a particular publish, subscribe, or PubSub backend service, something like an Azure Service Bus. I'd have to wire up the service bus code within my publishers and within my subscribers, and I'd have to think about all of that plumbing in my application code. Instead, I can now have Dapr offload that implementation and say, hey, Dapr, I want to go publish a message. Please handle the publishing of that message to whichever backend store I choose, and then handle the wiring up of each of the respective subscribers. And so you're really offloading a lot of the responsibility that you would have in that plumbing code to the Dapr sidecar. So you have your application code that's written in any framework. You're using these HTTP or gRPC APIs to talk to Dapr. And as mentioned and as kind of alluded to in my discussion right now, it runs as a local sidecar library that's loaded for each of the services. So as my service is coming up, I will have a Dapr sidecar running alongside of it. Even if I'm running, locally, or if I'm running in Kubernetes, it'll look very similar. And that sidecar is going to handle a lot of the offloading for me. So let's take a quick look at the architecture to once again dive a little bit deeper. So as mentioned, let's imagine we have two application services. We have application A and application code B, both of which make up an overall application that's composed of these distributed services. Each of those services will then have their respective Dapr sidecar, and they will use either HTTP or gRPC to communicate to their Dapr sidecar. Each of those Dapr sidecars, very similar to how Service Mesh operates, as we talked about on the previous session. It operates as this kind of network for communication from sidecar to sidecar. So very similar to a Service Mesh, the Dapr sidecars communicate with each other and can enable MTLS, and those communicate via gRPC. So basically, we're having service code talk to their direct Dapr sidecar, and then the Dapr sidecars are handling the communication between each of those services. So it acts as kind of that communication mesh, if you will. And then that Dapr sidecar, not only does it facilitate communication between the other Dapr sidecars running, it facilitates interactions with and connections to the building block components we've chose to implement. So within each of those building blocks, there are X number of implementation components that you can actually leverage to implement that functionality. So for PubSub, for example, I could use NATS, I could use RabbitMQ, Azure Service Bus, Redis, whatever. The backend store doesn't really matter. That's pluggable. The nice thing is I'm abstracting that away, saying, hey, Dapr, go publish this message. And Dapr is handling all the heavy lifting and connecting to that backend implementation of the component itself. And so the same works with bindings, observability, state stores. It's really pick the backend of your choice and abstract it away via this Dapr HTTP or gRPC endpoint. If we move into what this looks like on AKS or in Kubernetes in general, you'll think of the Dapr sidecar and the application code as being two containers running within the same pod. So those will be co-located, they'll communicate over localhost, they'll be scheduled on the same underlying infrastructure together because they're in that single pod. So you have your application service running. So I'd have service A would have its own pod with a Dapr sidecar, service B and its own pod with a Dapr sidecar, so on and so forth. I'm still communicating with the Dapr sidecar via HTTP or gRPC. And then that Dapr sidecar is still offloading responsibility and making use of the components that I've implemented via a series of YAML files. The sidecar is also talking to the Dapr control plane. So things like the actor placement service, which is really all about if you're using actors. So you don't need the placement service if you're not mapping, tables to a specific, using mapping tables to map specific actor instances to a pod. So that's an optional container that you'll, or custom resource definition to run on Kubernetes. Then we have the sidecar injector, which is basically going to be that mutating webhook that runs whenever I create a new instance of my application code. So if I've said, hey, I'm creating a new deployment for service A, I have an annotation that Dapr is enabled. That means that that sidecar injector will make sure a Dapr sidecar is then injected into the same pod. And then we have the Sentry service, which really focuses on things like creating the X509 cert, the SPIFFE identity. It'll enforce things like access control lists, and then it will also do all of the MTLS if you have enabled MTLS within your cluster. And then last but not least, we have the operator, which is really just looking for updated component implementation. So if you think about those components, things like the bindings, the state stores, all of those are just going to be YAML files, just configuration we set up to let Dapr know which of these backend stores that we want it to use and abstract away from our application code. So big call out here is that there is a Dapr AKS add-on that is in the works. And so essentially what this will mean is when you're creating a Kubernetes cluster in Azure, going through that AKS creation process, you will have an add-on that essentially allows you to deploy a managed Dapr control plane to your Kubernetes cluster. You can also enable it in high availability mode to make sure that it is resilient. And you can enable the Dapr dashboard as well, which is similar to what the Kubernetes dashboard will provide to you, except it gives some insight into those Dapr sidecars, the various services in which a Dapr sidecar has been injected, which components you're making use of, and the scope of those components, things like that, all that goodness. So while the Dapr CLI is really easy to use today, and there are VS Code integrations with Dapr, this will make it even easier because you're really offloading the management of that control plane, as mentioned, to Azure, very similar to how running Kubernetes with that managed control plane makes some of that operationalization of Kubernetes easier because you're not having to manage all of the bits and pieces and making sure that they're up and running. We'll handle that for you. So want to switch gears, talk a little bit about KEDA. Won't go into too much detail here, but do just want to call out how awesome this project is. I'm a huge fan. If we have time at the end today, we'll do a demo of kind of a Dapr plus KEDA application. Pretty simple. But if we don't have time today, I can send you some reference links to some other great demos we've done within our YouTube channel. And then also I'm going to record the demo and I'll make sure that it's in the same playlist as the preceding web series. So what is Kubernetes based event-driven auto-scaling? What is this KEDA project and why do we care about it? So basically it's a lightweight component that can be added to a Kubernetes cluster, and it'll run alongside your horizontal pod autoscaler, which is essentially how we scale pods within Kubernetes, right? We see, hey, there's a CPU or memory spike within this particular pod. We obviously need to scale that out using the HPA in order to create additional pods to handle the workload. However, KEDA is basically kind of adding and abstracting on top of the HPA in order to think about how we can scale based on other metrics outside of CPU and memory. So if you think about things like, hey, Azure Functions, for example, they can scale or they run based on, the number of messages in a queue or the number of messages on a topic. And that's kind of what KEDA can provide to you. So you can say, hey, I want to scale based on, queue length instead of CPU and memory, because CPU and memory aren't always going to be the most accurate or the best type of scalers for our particular service. And so KEDA is a really interesting project that was basically developed jointly by Microsoft and Red Hat. And then in 2020, in April of 2020, so about a year ago, it was donated to the CNCF. And so it gets a lot of that open source community contribution, which I think is really valuable. And it can be used on any number of Kubernetes objects. So think about, you can scale deployments, you can scale jobs. So it doesn't just support, pod scaling. It can support at higher levels of Kubernetes object abstraction. And then there are out-of-the-box scalers that you can take advantage of that are already built out. And so things like Azure Service Bus, for example, in the demo I was going to show is a really great example of that, right? Scaling based on the number of messages in a queue or topic, whatever makes the most sense for you. And it can run alongside services, obviously, in any Kubernetes cluster. It doesn't have to be in the cloud. It can run on premises as well. So as I mentioned, this is essentially how it will work. So whenever you scale, KEDA actually has functionality where you can scale a pod or a deployment to 0, and that's not something that the HPA traditionally supports. And so basically the scaling from 0 to 1 or 1 to 0 replicas of a particular object, whatever you're choosing to scale, is handled by KEDA. And then KEDA will essentially work with the horizontal pod autoscaler when you're scaling from 1 to many or many back down to 1. And that's all happening through these two KEDA pods, one of which is the agent, so doing that 0 to 1 or 1 to 0. And then one is the metrics pod, or I think it's called like operations or metrics is the name of the pod in the cluster whenever you actually deploy KEDA. And what that's doing is actually using the metrics server to tell the HPA to scale up or down based on whatever criteria you set in the Kubernetes object that you deployed. Yeah, there we go. The KEDA operator metrics API server is what that pod is called. So KEDA can also be used in conjunction with Azure Active Directory pod identity. So I just wanted to call this out. When we're doing our KEDA deployment, obviously KEDA needs to be able to operate and interact with whatever that backend scaler is we choose. So for example, in the demo that I would reference, KEDA itself, these, the KEDA pods need to be able to interact with my Azure Service Bus instance to understand, how many messages are on the topic or on the queue. And so you have to be able to give it certain permissions in order to do that. And you can do that through Azure Active Directory pod identity. So abstracting away, not only, you want to have secure configuration, connection strings, all that good stuff, but you also want to make sure that you're giving the appropriate privileges in the most secure way to the KEDA pods that are running. And so you can do that by using Azure Active Directory pod identity. So just wanted to call that out, as that is something that we touched on in the previous webinar. So one really interesting thing to think about is Azure Functions, right? So we've talked a little bit about how Dapr makes use of input and output bindings similar to Azure Functions. And then we've talked about KEDA. And it's like, hey, if I'm using Azure Functions, why would I need KEDA? Well, Ray will touch on this a little bit more, but we have provided a way in which you can containerize the Azure Functions runtime and run it in a self-hosted model. And so if you wanted to run those Azure Functions on premises or in another cloud provider, for example, KEDA is a really great way to make sure that you can scale those Azure Functions based on those traditional event-driven approaches that you would use, or that we use on Azure to scale Azure Functions. So if you want to have, for example, an application that's running alongside other Azure Functions and you want them to all run in Kubernetes together, this is a really great way to make sure that those Azure Functions are being scaled appropriately based on those input and output bindings of your choice. And so just wanted to kind of call that out if there was any confusion there. And once again, I'll try to go into that demo in action if we have time. I think we're probably going to be up to the wire. So once again, that'll be recorded and in the same playlist as the other components. So I'll walk through this whenever I actually do the demo. I'll make sure to kind of touch through a scenario, talk about how we actually go and work with Dapr to deploy a component, to wire up pub sub, and then we'll talk about how we can use Azure Key Vault from a security perspective, and then I'll show you how to make use of KEDA with Azure Active Directory pod identity. So definitely keep an eye out for that. So now that we've talked a little bit about Dapr and KEDA, I also want to just briefly touch on Visual Studio Code. So Visual Studio Code is really a very powerful IDE, one of the most popular IDEs, I believe, based on the open source community and some of the data that's come out of some recent surveys. But it's really powerful, and we've done a lot to make sure that we're integrating extensions that make working with Kubernetes on Azure or really anywhere easier from a development perspective. So just wanted to encourage, if you haven't already checked out Visual Studio Code, please check it out. Make sure that you have things like the Docker extension installed, and specifically the Kubernetes extension that the Microsoft team has invested heavily in. So the Kubernetes extension makes it easy for you to visualize and work with your Kubernetes clusters in a visual way. So you can view all of your clusters, you can drill into workloads, see services, pods, even nodes that are running on particular clusters that are within your kube config. You can also browse your Helm repos. You can install charts into your Kubernetes cluster. A lot of this, you can do with your CLI, but having this visual aspect is really beneficial. It also produces things like IntelliSense whenever you're creating Kubernetes resources, Helm charts. You can actually view diffs of your current resource state against your Git repo. There's a lot of powerful stuff here. So I want to encourage you to add that extension in. And then we also have one specifically for AKS that allows you to interact with your Azure subscription and integrate some of those Kubernetes clusters into your local development environment. We did have our project, an open source project called Draft, and Draft helped with the local tooling or the local development experience by basically containerizing your application based on the application language and the framework. And then it would basically kind of create a dev sandbox Kubernetes that you could then interact with and see how your application translates from the local development environment to a Kubernetes cluster when it's up and running in a container. Now, I will say there are other great projects out there that still provide similar functionality. So I recommend you checking out things like Scaffold and Tilt, both really powerful developer tools that I think a lot of organizations take advantage of and make great use of. And so if that's something you're interested in, experiment with and talk to your development teams to understand what tooling might be best for them and the way that their development teams, are currently set up, and especially the level of Kubernetes experience is a big aspect there. So I wanted to highlight one of the really cool tools coming out of Microsoft to make working with Kubernetes a better experience for developers. So if you've ever heard of Azure Dev Spaces, it was essentially an AKS add-on that was free to customers that went GA in May of 2019. And basically the entire value proposition was to debug and test code changes in the context of a larger application. Now, one of the things that the product group found is that the value prop of that really resonated, right? People did want to find ways to interact with a variety of microservices and get a debugging experience, even if those microservices were running inside of Kubernetes. And they also wanted high fidelity with the type of environment they were going to deploy to. So when you're doing local development and you might have, let's say, 6 or 7 microservices that make up your application, you're sitting in Visual Studio Code, you're running all of them locally, you're trying to debug all of them. That can be really difficult. And it has very low fidelity to the actual environment in which your application is going to be running. And so with Azure Dev Spaces, essentially you would have multiple services running in your AKS cluster. The baseline essentially of your current application. So let's say we had service A and B, they'd both be running in our Kubernetes cluster. Let's say I had service B that I was working on locally. Maybe I had a user story to make some changes to service B. We would basically create some functionality that would allow you to containerize that locally running service B and run it against the services running in your Kubernetes environment. Now, the challenge with that is it was still challenging because you were still working with images and Docker files and containers locally. So for developers who didn't really want to have to learn Kubernetes or who weren't really container savvy, they weren't really getting the traditional development experience because they weren't just developing, in their local environment. They were having to worry about, hey, I'm making changes, it's syncing into a container, that container is then syncing up to the Kubernetes cluster. And so I think that friction made the product group consider, are there ways that we can make this a little bit more frictionless? And so that's what the goal of Azure Bridge to Kubernetes, or just Bridge to Kubernetes, is trying to do. So it's basically a client-side tool that's currently supported in Visual Studio Enterprise and VS Code. And you can run and debug your microservice code on your development workstation while still connected to the Kubernetes cluster that might have some external dependencies or other application services. So it's making development of microservices easier, helping expedite that inner loop so you don't have to go all the way through the CI/CD process in order to see, hey, my service code A doesn't interact well with the currently running B, or maybe there's a downstream change or an impact in service C that I wouldn't see until I had gone through and deployed service A to that cluster. And so we're trying to find a way to make that debugging experience as parallel the traditional monolithic development debugging experience as possible. You can also work in a variety of modes, which I'm going to walk us through in just 1 second, and you can connect to any Kubernetes cluster. So it doesn't just have to be AKS. You could be working on a local Minikube environment, a kind cluster that you're running, which is Kubernetes and Docker. There are a ton of different options for you from a Kubernetes development experience, and you can choose to point bridge to any of those. So let's actually see this in action. So let's say we have a pretty basic to-do application. You can basically add items to a to-do list, see how many are completed, remaining, so on and so forth. And so I've deployed this application to an AKS cluster. It's running, and I have kind of that baseline. And this could be in a particular namespace, a dev namespace, a sandbox namespace, team A namespace, whatever you choose based on the way that your development teams are set up. And so if you're a developer that's working on just a single service within this application, how do you make sure the changes that you're working on are going to interact well with the context of the larger application? So once again, I could spin up all of these locally and have them all run on my local box, but we're not going to get very much fidelity with that remote environment or that Kubernetes cluster. And then basically I could say, well, I'm going to go fully remote and I'm going to work on the code locally, but then deploy the changes into the cluster itself, which makes it hard to get that shift left and get the immediacy for the dev inner loop, because you have to containerize in order to do the proper debugging. You have to set things up. And so not super fun, right? And so bridge kind of falls in the hybrid space. So I'm working locally connected to this deployed environment to work with these other services, and then I don't have to worry about doing any kind of containerization. So the stats API on my local machine is totally just a single, just a regular C# project or whatever language you're developing in. It does not have to be containerized. You don't need a Docker file, so on and so forth. So using Visual Studio Code, using the Bridge to Kubernetes extension or the Kubernetes extension, which it's integrated with, I basically am going to define some kind of connection to the cluster that I would like to point to, and then I'm going to persist that connection. So once I've done that, I can basically then say, okay, my developer workstation and my Kubernetes cluster have now been connected, and I want to basically redirect traffic from the stats API that's running in the cluster to my local instance. So in this case, when I hit the front end and I make a call to change something about the to-do, right? I add something to the to-do list, I take something off, and then I want to basically get stats around the number completed. Instead of going to the baseline version, we're basically going to have a bridge agent that redirects that traffic to the local machine, uses the stats API, hits local debugging points, all that good stuff, and then we'll use the rest of the external dependencies that are running in the cluster. And so this is if you're running in shared mode, and there's also isolated mode, which I'll explain in just a second. But you can see here how this really will make your debugging experience really seamless, because you basically only have to have on your local machine what you are developing, and then you can essentially work with these other services and redirect that traffic back. So if I want to work in isolation mode, it's going to look very similar, right? My developer workstation and my Kubernetes cluster have become connected through this bridge extension that I'm using. And instead of redirecting the stats API for everybody that's hitting the front end in that particular cluster namespace, instead I'm going to have a bridge agent that runs alongside of the currently running stats API in the cluster. And when I hit the front end, I'm going to have a header, and that header is going to be propagated. And that bridge agent will say, hey, I see that you have Nick G1234. Therefore, I'm going to redirect that traffic back to your cluster. But if anybody else hit the cluster, they would hit the stats API running that baseline version. So you could have multiple developers working on independent changes on independent services and interacting with one another's, currently being developed version or the version that is baseline within the cluster. And so lots of cool configuration there. So I'll pass it over to Ray. We're about halfway through at this point. He's going to cover a lot of good stuff around GitOps, Azure Arc, and some of the other platform integrations on Azure. So Ray, I'll hand it over to you at this point.
Thanks, Kendall. Now to do the presentation swap over. Okay, I'm presuming that's loading up as expected. So we'll move on. So at this point, we're going to talk about GitOps and essentially multi-cloud and how to operationalize your cluster or clusters across different environments. And so the major things we're going to take a look at, again, Helm versus customized, and then we'll eventually get to the idea or concept of GitOps, which ultimately helps us to maintain sort of a semblance of organization and like structural deployments across either single clusters. So if we wanted to redeploy it over and over again, if we want to have authority over what gets deployed, as well as in our multi-cloud environment, how to actually manage this across different Kubernetes clusters in different providers or back on-prem, or if you're running, Linux on a toaster, runs on a toaster at home underneath your desk somewhere. Okay, so switch to next slide. So sort of first steps into this foray of GitOps and managing your cluster is how do we actually package up our Kubernetes manifest file? So we have a good way to package up our containers. Do we have, in fact, a good way to package up our way of deploying it within our orchestrated environment? This is Kubernetes. The two sort of leading ways to do this is, well, actually three. If you think about just managing your manifest files, your vanilla Kubernetes manifest files themselves, that's great, but it doesn't really give us a lot of power, flexibility in terms of how we want to templatize. I think that's the way to pronounce it, or if that's even a word. How to templatize the actual manifest themselves. And so the next natural evolution or progression of this is, are there tools within this space that allow us to do this? And yes, the answer is yes. The two in particular, again, Helm or Customize. The leading sort of right now de facto package manager is Helm. And this is usually how most organizations or most companies out there package up their particular software vendor version of something. Maybe it might be like an open source firewall that they have support for. Like you could, in theory, spin off like a consulting company that does like a pfSense firewall or something like that, make your own distribution of it. How would you package it up? How would you actually say, this is my opinionated way to deploy it repeatedly? And so in this case, you can use something like Helm, where you can, it has got a templating language built in. You can do things like interpolation. You can set default values. You can even set conditionals in terms of the combination or complex combination of things like these specs or these properties or these annotations exist. Therefore, this is the output, or this is the value that will be created. And so what you can get out of Helm as well is that you have the ability to distribute it via any sort of OCI registry compliant container registry. So if you've got Docker Hub, if you've got your own container registry running in your own private environment, Key or Quay, I always forget how to pronounce it. I think it's tomato, really. If you've got Azure Container Registry, those are OCI compliant registries themselves. So if you do a Helm push pull from those registries, you immediately have this central artifact server essentially for Helm available to you. It's a good tool if you've got a very complex deployment, a lot of different things that you want to kind of bake in and have the ability to change later on, version control with Semver and things like that. Great. It does, however, require you to have a separate command line tool. In this case, it's called Helm. The version that we have now, Helm 3, it's just a single command line. So basically, under the hood, it will locally compile and basically interpolate any of the things that you're passing in as parameters or the variables that you need to create. And then it ultimately compiles to a Kubernetes manifest file, deploys on your behalf. It's able to track the different versions that you've deployed into a cluster. So you could reuse the same Helm package over and over again within different namespaces for different teams. So if you want to deploy like MySQL over and over again with basically the same configs or slightly modified configs, you can do so. And you can deploy them into different namespaces for your accounting team, for your sales team, etc. And you can run like a Helm list against a namespace to see which of those packages have been deployed. If you want to do it multiple instances, even within a namespace, you just rename the deployment itself by a different name or version if you want to do as well. So it's very powerful that way. After that long explanation, the shorter one and one that's really good for smaller projects is a tool called Customize, which is baked into the kubectl command line. So it's there already. However, the version that you get with kubectl may differ from the latest and greatest customized standalone CLI tool. So there might be some sort of version drift between the two. Needless to say that it's a simpler tool in comparison to Helm, which is great for smaller projects. So if it's an internal team project, maybe it's something that you don't necessarily need to deploy at scale in terms of repeatability across organizations with a lot of different things that you need to change, track, or maintain. Customize is much simpler. You just add one sort of customized YAML file within your project itself that defines where are the locations for all the different manifests, which include like CRDs, ingress, rules, your actual deployment, you name it. You just tell that customized file where to locate those manifest files within your project, and you can override them. So you can do things simply by passing in another YAML file that will directly override the definition for those objects essentially in Kubernetes. So you can list properties that don't exist, and so it'll append or merge essentially the existing manifest file in there, and you can override values basically this way as well. So once you do like kubectl customize and you redeploy, it will know how to manage that on your behalf. So the ease of this, of course, is that you don't have to traverse a fairly complex organization of templates and values and things like that, like you would in Helm. It doesn't necessarily have the same powerful syntax or interpolation language or template language that you would have in Helm, but it's much more straightforward. So if you are sort of dipping your toe into this world, if it is a fairly straightforward, maybe only a handful of deployments, the customized path may be a better one for you to get started with. And certainly, I would say you'd get up and running a lot faster customized than, say, Helm. But as soon as you're trying to package it up as as something that you want to distribute, that you want to maintain and support at a much larger scale, Helm is likely your best tool and choice from there. So what does this actually get you if you go with one tool over the other? Well, it gives you the ability, again, to be able to define a fairly opinionated way to deploy your particular instance or your particular configuration of your application. Again, if it's a MySQL deployment, etc., you have a way to pass in these values over and over again, and you also have a way to modify these on the fly dynamically if you needed to as well. So if you had an automated pipeline, you want to pass in values, you can totally override them via the command lines. With Helm, you can set the parameters themselves, set the settings via the command line directly to override even whatever's in your values.yaml file. Okay? So that's the starting point. So that's great. Now we have a pattern of how we can actually do this over and over again manually. So if I wanted to run these commands myself, kubectl, apply, or if I wanted to do Helm install, if I wanted to do the customized path, okay, great. How can we do this at scale? Right, we can do it via pipeline, like I mentioned, or sort of the next step of things. So the push model being our automated pipelines. We've got some like Azure DevOps, GitHub Actions, Circle CI, Bitbucket, you name the tool of choice. That's a push model, right? We put credentials, we put the ability, the onus on that into the pipeline. It's a bit better, actually much better than if I were to do it by hand on my laptop and run the commands on my laptop and push it to the cluster. This automates it into a pipeline. I can check in the configuration changes that I've made to my manifest files, Helm, or customize to a repo. That'll trigger my pipeline, and great. Credentials are stored inside the pipeline, push it to my cluster. But the problem with this is we do kind of expose the credentials to the pipeline itself. Anyone who has access to the pipeline could, in theory, make modifications accordingly. We do have some guardrails in place in terms of ensuring our sysadmins or developers are following good practices by submitting PRs, etc. to the pipeline, okay? But it is potential leak in that sense in terms of the credential. So that kind of is a con, but it does work for organizations. It's a lot fewer things to set up. I just have the pipeline, it pushes out, and I can review and update that iteratively as I'd like. The alternative method, and typically this is a little bit more in line with what true GitOps is in some practitioners' eyes, is more of a pull model where let's reverse this a little bit. Instead of putting the credentials and having everything driven through a pipeline that has to go through a lot of hoops in order for it to actually operate, what if we put an agent into the cluster and give that agent credentials or authority over the cluster itself directly? Credentials aren't leaked outside of the environment itself, so it's not exposed anywhere outside of Kubernetes. it's inside Kubernetes itself, running as a separate pod or a set of pods, depending on what you're running. You can also scope it down to a given namespace. So the credentials are only good within that given namespace, etc. And the other good thing about this too is that you also have an agent that's actively watching your system. In a push model, once I've put it through the pipeline, it's sort of one shot. It goes through and it applies the configuration. There's nothing sort of quote unquote reconciling any changes that are being made against the system, whether again the system automatically scales up, or scales down, or someone else outside of my pipeline applies a kubectl command directly to it. Okay, in a push model with the agent, the great thing is the agent's constantly watching, so you can set sort of the red, yellow, a green sort of way of doing things where if someone comes in, makes a change, do I want to send an alert? It will automatically be able to pick up on that. Do I want to, soft, kind of, again, same idea, send an alert, let someone know that, an actor has done something, whether good or bad? Or do I want the red hard stop, like anyone tries to make a change, block it or roll back to a previously known good version? Okay, so the pull model has benefits in that sense as well. Okay. What this also provides in the pull model is that it's watching over a Git repository. Same repository you'd use in a push model, but in this case, it becomes authoritative. So again, it will ultimately reconcile what it should and shouldn't deploy. If something changes that it shouldn't have been, it knows to roll back and operate against that. I make a PR update, and now increases or decreases depending on that depending on what that PR was, whatever the update was, and now the agent knows how to reconcile against that accordingly. So borrowing from our friends at Weaveworks, they have a tool that directly implements this idea concept of GitOps. Their agent in particular is called Flux. And again, the idea is that it's an agent inside the cluster watching for a given repository, or it can also look for new images within your given container registry and act against the cluster accordingly. Now, what you can see in this particular model is that as a developer, as a sysadmin, I make the changes to either source control, so Git, or a container registry. And again, the agent picks that up. The Flux CD agent picks that up and applies it against the Kubernetes API directly, according to its ability to do so, right? So we can use role-based access control, which we talked about in the second webinar. So go back and check that out, and then can operate accordingly. In this model as well, we are also trying to avoid the ability for external actors to apply rules against the cluster, even if they have the credentials to do so. Perhaps we want to deny them altogether, maybe in a production environment. We want to do it in lower environments, but in this case, we want to avoid that. So one way, of course, is to revoke anyone or do not hand out credentials in the first place. Another one is to make sure that we have the policies in place to block that from happening altogether. Just name some tools in this space. As I mentioned already, we've got Flux from Weaveworks. Argo CD is also another popular one. Sort of my segue into the next section or area is the idea of Azure Arc for Kubernetes, which is our tool or our supported tool on our platform to provide this GitOps model as well. So Azure Arc. So overall, Azure Arc is not just for Kubernetes. We've got our specific flavor of Azure Arc. That's Azure Arc for Kubernetes, if I haven't said that enough times already. We have the ability through Arc, just as a broader picture of things, to manage different services across environments. That's on-prem, your edge compute. So these might be IoT devices, as well as multi-cloud, as well as back on-prem as well. Very important for anyone doing quote-unquote hybrid cloud, so to speak. And so what this provides you is the ability, the one dashboard, if you want it to be on Azure primarily as your primary provider, integrate this within the Azure portal experience, right? So an ability for you to run, data services, VM services, management services, be able to have security policies and things like that, push from basically cloud down to ground or down to other environments from there. So single pane of glass for that. What we're able to do for the most part is to, again, have a centralized way to organize, manage, and have governance across environments. So again, the policy aspect of it, do we want RBAC enabled for virtual machines? Do we want to push down agents that will enforce those policies accordingly? Do we want to set some kind of minimal amount of applications or services on top of that compute within given environments. In some scenarios too, you want to manage SQL and the various flavors, MS SQL, MySQL, Postgres, into those areas or deploy it all together. There are facilities to do so. Okay. So custom, customer scenarios, in this case for Kubernetes at scale, this really pertains to the fact that if you are running a handful of Kubernetes clusters, it doesn't seem to be that big of a deal, right? I can have a separate pipeline for 2, 3, maybe even 10 clusters. But as soon as I'm starting to do cross environment, I have probably about 5 more, 10 or more clusters. It can get a bit unwieldy. My DevOps pipeline can look pretty ugly. A lot of spaghetti pipelines, a lot of like customization for this environment and another. Wouldn't it be better if we had a centralized location to store those configs for one, and be able to have a centralized location to basically manage the push down or the installation of our GitOps agent, so to speak. And so this is where we're moving towards when it comes to Azure Arc for Kubernetes itself, a way to bootstrap that environment, a place to essentially, after clusters created, be able to push down the agent into the environment, and for it to immediately know which repository it should be looking at in order to define what our environment should look like. Move along here for now. So just kind of moving ahead from that previous slide to this one, what I wanted to get was, again, we have policies that you're used to if you're an Azure administrator already, if you're used to Microsoft's tools and services, the ability to actually manage all these pieces. So the tool that you're used to, whether it's Portal, the CLI, some form of Azure SDK for you name your language, .NET, Java, Ruby, JavaScript, or Node, you can manage the exact same resources accordingly, push identity, role-based access control, policies, create groups, etc. And you can do this across the whole hierarchical process that is Azure Policy and Azure Management, blueprints, and all that, and be able to, via the Azure Arc for Kubernetes agents or resource provider itself, be able to push down the agent into Kubernetes, be able to install it. You can install it as a one-click sort of install if you're deploying AKS itself natively inside Azure. You can also install the agent as part of a Helm, as I mentioned before, a Helm package into your cluster. So again, if that cluster is not within Azure itself, meaning the Azure Arm API has no way to control that resource, if it lives on premises, if it lives in a cloud provider, or if you're running your own like Raspberry Pi cluster, my equivalent of a toaster that can run Linux at home, you could install the agent accordingly as well there. And once it's in there, it will then contact or reach back out to Azure itself and be able to pull down policies that you've defined accordingly. The benefit and the reason why we're doing it this way in terms of adding an agent inside the cluster is that we're not really creating anything that is extra work, so to speak, against the cluster. It's nothing like proprietary, or let's say proprietary is the right word. It's nothing that's going to overcomplicate it. It's not. We're going to be using essentially Kubernetes or the API server primitives, right? It communicates to Kubernetes the same way as anything else does inside your cluster. And so this allows you to still leverage Kubernetes native tooling, how you would in the future provision your cluster itself, do upgrades and management in the given environment that you're running in. So, again, in Azure, we upgrade in a certain way, in another provider another way. On-prem, it might be direct via your hypervisor of choice, etc. And so we'll have the ways to kind of hook into that as a result. Main takeaways: central management, at scale control, whether it's a handful of clusters all the way to thousands of clusters. It is following best practices in terms of I would say it's still kind of emerging GitOps space in that practice overall, as well as giving your team, if you are familiar with it and prefer the model of managing, using the Azure management way of doing things. So you can set, like we had described in the second webinar, Azure policies, etc., and how to push that down into the cluster. This also still gives you the ability to provide the cluster with the Kubernetes native way of doing policies, and having the agent, again, checking against the repository, apply those given resources or policies into the cluster. Just as a moment or segue into this, just going to kick it back to Kendall to talk about Dapr and Azure integration again one more time. It's going to be a short one because Kendall already covered this earlier.
Yep, perfect. Just wanted to talk a little bit about the fact that, we talked about the Dapr AKS add-on, but we're also really bringing Dapr as a strategy into the platform even further than that, right? So we want you to be able to leverage Dapr as this, event-driven runtime running alongside your microservices, regardless of where you are choosing to host those. So, as part of Arc, obviously managing Arc, managing multiple Kubernetes clusters across cloud providers or on premises, you can now also get that managed control plane for Dapr that you can instantly install by just clicking basically a box. So keep in mind, this will definitely be a really valuable approach if you do choose to use Dapr as that level of abstraction away from your backend services. You'll also have that kind of managed, deployed straight to cluster approach for you through Azure Arc. So I think it's definitely that hybrid story is certainly coming along, and I think Dapr is going to be a big part of that.
Awesome. Thanks, Kendall. That's now a good segue, another segue, into native application platform integrations with Azure, as well as sort of the future that we see Azure services as it pertains to Kubernetes environments. Dapr being a good example where it starts off as a service inside Azure, and then it kind of migrates its way into sort of a Kubernetes native experience, so to speak. So we'll get to that in a little bit. Okay, so key integrations, Kubernetes and beyond. Do the Tim Allen voice and the Buzz Lightyear, probably how I do it, but clearly I failed on that part. So native integrations natively within Kubernetes, even vanilla Kubernetes, if you roll it yourself on VMs within Azure, or for a reason you're doing on-prem, but you still want some access to resources in Azure, kind of extending from on-prem back into Azure itself. The top ones, of course, the Azure CNI, the Container Network Interface. So this is what is deployed in the AKS advanced environments that you have, or advanced networking environments, that directly has your pods as being issued IP addresses inside your virtual network, inside your Azure VNet, as opposed to the quote unquote basic networking inside AKS, which is KubeNet, an additional network overlay on top of your VNet. So Azure CNI, again, IPAM management, right? Like your IP allocation, how it's going to hand it out, that directly works in there. It has the ability to route traffic accordingly. It's all built in. So when you deploy in an advanced networking model, or if you decide to turn this on and roll your own, it automatically knows how to speak to Azure itself, provided you've given it service principal and MSI that can do so, to, again, get an IP address for your resources inside your cluster, and knows how to manage that on your behalf. The next level, the one that's, to me, a lot more complicated kind of thing. It's not like set it and kind of forget it. There are some dimensions to storage, but it's sort of the same idea or premise that's it's there for you to use, consume, just like the CNI is the CSI driver, so the container storage interface drivers for Azure specifically. And so what this provides you is the ability for you to define your persistent volumes, or your volumes themselves. In an AKS environment, you've got two default storage classes, Azure Disk and Azure Files. I believe now you should be able to see Azure Premium Managed Disks as the default inside your cluster. But this ability, again, presuming your cluster has an identity within Azure, either Service Principal or MSI, which we covered in webinar 2, as long as that identity has the credentials, the roles that allows it to provision disks and files within your resource group that you're deploying Kubernetes in, it can reach out, talk to Azure, and go, hey, I'm deploying a pod. Give me a managed disk that it can mount to, so it can write and persist information. Or perhaps you want to manage this across multiple pods against the same file store. You can provision something like Azure Files. And so Azure CSI gives you that facility baked into the Kubernetes upstream itself. The last part of this CSI integration is Azure Key Vault, which is, I believe it's still kind of in the works, but I've seen a lot of customers use it in production already. It gives you the facility, again, given that your credentials are correct, can, instead of storing secrets directly inside Kubernetes itself, the CSI driver for Key Vault can broker that communication to an actual Azure Key Vault, HSM-backed, this whole fully encrypted, actual true secrets environment stored in there, and then be able to reach in and grab it for you for your given environment based on your access control as well. The next level of integration are sort of more platform or out-of-the-box experiences, right? So we want a full-on sort of machine learning SDK. We've got something called Azure Machine Learning itself. It provides a Python SDK that allows you to do a number of things. The first and easiest, if you want to just get started from a data scientist perspective, but you're not necessarily a Kubernetes administrator, the AML SDK allows you to provision a Kubernetes cluster in a few, easy Python, lines of Python code itself, as well as the flow in which you're going to be running your test environments in, right? You're going to train your models, etc. It's going to have an idea of how to provision an ML model registry, version that, and check it in, and then deploy it into a Kubernetes environment. So that's sort of level one. Out of the box, you can define that cluster. The sort of level two after that is you still have those great things where you can tie into cognitive services, be able to experiment on your machine learning with experimentation, tied in certain databases, etc. But you don't necessarily have control, or maybe your organization hasn't given you the authority to spin off your own AKS clusters. Instead, what you might have is a model where someone in IT, a sysadmin, or someone else like that who has control over Kubernetes or must approve that cluster be created, or maybe the one is already existing, provides you the facility or the ability to adopt essentially that cluster and hook it into AML SDK. So you don't have to roll your own. You can leverage an existing cluster, one that's been given to you specifically for your usage. So if we go back to webinar 2, where you might have more requirements, let's say, around how the cluster should be provisioned, someone can do that, ensure those guardrails are in place, and then, again, you adopt that Kubernetes cluster accordingly. Serverless Kubernetes. So this is referred to as virtual nodes. In previous documentations or the previous version of this, you might have heard the virtual kubelet. Virtual nodes is the sort of next evolution of this. This is an open sourced tool that we have donated to CNCF. But basically, this allows you to take advantage of the various serverless container services out there, or serverless container platforms that are out there. Azure's particular version of this is called Azure Container Instances. And from the perspective of your Kubernetes cluster itself, you can kind of treat ACI, or the Azure Container Instance Service itself, as a sort of infinitely sized node, where you can basically provision as many pods as you want inside ACI on your behalf. The advantage of this particular service and this integration is that you can take advantage of unknown traffic bursts, right? So steady state, my cluster runs at, let's say, 10 nodes, but all of a sudden we have like a Cyber Monday or massive retail event that we have unexpected, or we don't have a crystal ball. We don't know how much traffic we're going to get on that particular day or event, or something causes that traffic to spike. And so we can so to spin up a new node doesn't take a lot of time. Let's say in the order of like 2 to 10 minutes, depending on the size of VM that you want. But minutes isn't exactly the most reactive amount of time that we want. And so what we could do instead is attach either ahead of time or just leading up to the event this virtual node extension into the cluster. And what we can take advantage of are seconds, or in some cases sub-second deployment times, because the ACI service itself is basically a warm service. It's a a fairly large fleet of VMs that are already running that we have started up that can run containers. And so on a burst per second basis, and you only build on that per second basis. So if you only need for like 10 seconds, you only build for 10 seconds, etc. This can handle that burst until such time where the nodes that you need to run that steady state. So I need to increase it by 5 additional nodes, 10, etc. We could do so, and then once that is up and running, those nodes are now joined to our cluster. They're up and running and able to schedule workloads. We can cordon drain the workloads that are on ACI and drain them onto the nodes, so that we have that consistent longer-term workload operating. All right. So now coming kind of full circle from what we were talking about earlier with Dapr and sort of the evolution of Azure services to our logical progression of things. We are seeing, and our sort of strategy in the long term is being able to provide our customers the ability to run other Azure services that you are using today inside Kubernetes itself. And what are the sort of the why would you want this, so to speak, right? So if you're already using like Azure App Services, or in this particular case, where I want to talk about subset of that, Azure Functions or Logic Apps, you're used to it. You've already got the language, or the function, the code itself running inside Azure Functions as a managed service inside Azure, but perhaps you might be reaching some kind of limit where you would prefer to have a little bit more control over the environment. Perhaps it's a performance thing that you want to have more control over. You want to fine tune certain bits of it. Perhaps you want to move up beyond a premium SKU of Azure Functions and be able to manage how it scales in complete control of how it scales, so to speak, inside Kubernetes itself. And so what we do provide from an Azure Function perspective and Logic Apps and other services in the future is that we've containerized that runtime itself already. So if you've already written it for the Azure managed function service itself, you can actually just copy the exact same code or repackage it up into a container if it's not already in an Azure Function container and run it as a pod inside Kubernetes. And so you can take advantage of what Kendall showed us earlier with KEDA, and I have that on the next slide, how to actually scale this. Can you actually trigger that yourself? And how can you actually trigger it on metrics that perhaps the native Azure Functions platform itself doesn't know today how to scale on? And so you can use KEDA to listen to different queues that perhaps Azure Functions doesn't have the bindings for, triggers for, or you want to set it against certain custom metrics instead inside your cluster to scale up and down. What you can also do from social API management perspective is to self-host an APIM instance or multiple instances across your environment too. And this allows you to have a self-hosted environment. So maybe you aren't as satisfied with the way that APIM scales, or you want to again have more control, or you have the correct knobs and dials to tune that accordingly. You can be sort of the in control of your own fate, so to speak, when it comes to that. Right. So the future of this, of course, whether it is Kubernetes or not, is to containerize it. The ultimate goal is to make Kubernetes sort of the first class way of deploying it, regardless of where you run it, because that seems to be common substrate going forward across cloud providers, hybrid strategies as well as on the edge. But do expect this to be more and more prevalent as we move along. So just to take this idea again across Azure Functions in terms of how you want to deal with it and merging it with Kendall's portion of today's webinar with KEDA. KEDA gives you many ways to sort of inspect or watch over services, queues, events, etc., and be able to scale up via the horizontal pod autoscaler a given deployment. In this case, because we can containerize an Azure function and the future other Azure services, this gives you so that great hand-in-hand way of having complex ways to listen for external triggers and scale up our application accordingly. Dapr and Azure Functions. Kendall, do you want to talk about this a little bit more as well before we move on?
Yeah, not too much to talk about here. I think the biggest thing is just that Azure Functions does have a Dapr extension for triggers and bindings, as is mentioned, right? So basically you can interact with some of the Dapr capabilities. It's similar to the API management integration, where you can basically, in that self-hosted version, interact with Dapr as that runtime that abstracts away some of the implementations for your triggers and bindings, similar to how Dapr can provide some of that input and output binding functionality. So just wanted to call that out. The two can play well together, and there's definitely some work being done in order to help make sure that the experience when working with them is streamlined, and you can take advantage of what makes sense for you and your organization.
Awesome, thanks. And then the last part about Dapr and API management, essentially, where you're moving towards integration with the actual APIM gateway controller, and then being able to add as part of your deployment inside Kubernetes Dapr Sidecar, so that it can natively contact essentially all your other services via the sort of I'm going to butcher this, the Dapr native way of doing it, right? So you don't necessarily need to know the services themselves, as long as you have the ability to invoke the service directly or talk through HTTP or gRPC. It's all out there out of the box for you to consume. So it's a big note and something that's I think a pretty big game changer for most organizations. Yeah, so I guess that's pretty much the end of this particular webinar. I guess we had the live version of this out not long ago, and we had some Q&A in there, and we'll complete those Q&As that we couldn't cover within the live session itself and post that to the actual GitHub repo that we have already, which we'll include in the descriptions in the YouTube video. So I guess that more or less wraps up this webinar. If we go to next little bit, Kendall, this is your thing. This is your baby. So
yeah, thank you. Yeah. So the biggest thing is I just want to call out. So as Ray mentioned, over the next week or 2 weeks, be patient with us. We'll make sure we get that Q&A that was transcribed from the previous sessions up on the GitHub repo so that you can peruse through them. I know that we're going to put up some content from the previous webinar, and then we'll also make sure that we get this uploaded to YouTube and make sure that the repo is up to date. But please join us for a more interactive conversation moving forward. Obviously, we love doing these webinars, and I think it's been very valuable. But if you want to be part of an ongoing conversation around AKS features, cloud native ecosystem updates, we do this every other Thursday, 11 to 12 CST. And we have the Azure product group come on and also do roadmap updates about, the latest features and when things will GA. So if you have questions like that, those sessions are really great to join. So we look forward to seeing you there. And once again, we'll make sure that we add a series of links to that GitHub repo. I'm actively working on it. That'll be a great way for you to continue down this learning path and dig deeper into some of these topics as they, make sense for you and your implementation. So just thanks everyone for joining, and we'll make sure that we get that repo up to date. Just be patient with us, and if you ever need to reach out, you know where to find us on Twitter and LinkedIn.
Awesome, great. And then lastly, like all the different resources, this will be included in the deck, as they have been in all the webinars as well. So thanks for watching.